All right, in this video we are going to be talking about survey problems. We're going to start in this video just with this one two-circle survey problem with multiple questions. A lot of people get hung up on these and a lot of it's the language, so we're going to just talk about them. So the first thing we need to identify in any survey problem is the universal set and how many sets are within the universal set. So in this problem, can we... So which part of this is the universal set, Chris?
The 100 students.
The 100 students is the universal set. So I like to kind of just be like, all right, here's the stuff I need. Universal set, the cardinality of the universal set is 100. And then the cardinality of the commuter set, I'm going to just call that C. Is that C okay to you? C, the cardinality of the set of commuters is 75, and the cardinality of the set of transfer students that I'm going to call T is 40. So we have all sorts of information, and then anything where it's a survey problem with multiple sets in it kind of just screams Venn diagram to me, and hopefully it'll start screaming it to you. So before I actually draw the Venn diagram like you're used to seeing, I like to draw each of the sets separately. So there's 100 students in the universal set. There's 75 students that are commuters, and there are 40 students that are transfer students. So now I'm going to put it all together and hopefully in a meaningful way. So I'm not going to put any numbers in it yet, and we're going to figure out which numbers need to go in there first. When we're filling in the Venn diagram, the actual Venn diagram, not these sets out there, what should we fill in first, Chris?
You should fill in the intersection.
And down here, I didn't underline anything that's the intersection. Like, which part of this is the intersection?
The 20 transfer students who are also commuters.
Okay, that's right. And let me label some stuff here really quick. Okay, so the 20 transfer students who were commuters. So 20 of the transfer students were commuters, which means they lived within the set of transfer students, but also within the commuter unit. And that but thing's really weird. But and actually are the same thing grammatically, which is helpful later on. So 20 transfer students were also commuters right there. So we're going to put the 20 right there, which is going to help a lot. So next, we need to figure out how many go here, here, and there. So this set, how would you describe what happens right there? Who's in that little half moony shapey thingy there?
The commuters.
Okay, the commuters, were they also transfer students? If they're in this, no. Okay, so they're commuters, but not transfer students. Only commuters, not transfer students. Well, there were 75 commuters and 20 of them were transfer students. So how do we figure out what goes there?
75 minus 20.
Yep. And for a lot of people, it really does help to just write that down here. That's not dark enough to see. 75 minus 20 gives us the 55 who were just commuters. So 55. Do that work. If we are taking paper tests by the time you watch this video and you show your work and you make a subtraction error, then you can get credit. But right now tests are on Hux, so that's not going to happen. But just do the math. So here we need the transfer students who were not also commuters. So we're going to do the same thing here, 40, and we're going to subtract those 20 that were in both sets, which gives us a 20, which I hate it when I make up the numbers like this because then the 20 is in two places, but I'm sorry. So we've got 20 students who are just transfer students, but not commuters. And then what's left are the rest of the universal set of students. So this hopefully adds up to less than 100. 55 plus 20 plus 20, so 55, 65, 75, 85, 95, good. So there's 95 there. So there's 5 students out here who were not commuters or transfer students. So that should be good. So we've got the Venn diagram filled out. Now we're going to start answering some questions. So the first one is the one that we needed to actually fill it out in the first place. How many students were transfer students and commuters? And where did we find the and?
The and was in the center of the Venn diagram.
Yeah, in the intersection. So I'm going to write the notation for that too. So I just wrote the notation for that. The and is this intersection, which is the overlap here, which means it's those 20 students that were both. It was given, but they didn't say and so translating their language to the other. And I guess I'm going to go ahead and just write 20, how many students, and 20 students. That's a picture of students. All right, so next I'm going to come down to how many students were transfer students or commuters. What is how do you deal with or in math? Do you remember? What's the word for or? A lot of people forget that, actually. So what is it? Go ahead.
It's that symbol that looks like a U.
It's a symbol that looks like a U. Okay, and it happens to actually, what's kind of cool is the union symbol, it's called a union, by the way, which nobody remembers, is a U, and the and symbol, which is the intersection, kind of looks like an A. So it's nice that there's a couple little things to remind you of what's going on there. So and then the union, this is one of the things that confuses a lot of people. So the union, what does that mean? What does the union mean? I mean, obviously we just said it means or, but like, is it an inclusive or exclusive or? Like, tell me what does that mean when you say or?
It means it includes the center of the Venn diagram.
It's either purple or green or both. So the or in mathematics is always an inclusive or unless they tell you otherwise. So it means that they're either a commuter or a transfer student or both. So that should help a lot. There's a couple different ways to deal with this one. You can either do this formula that's probably in your book that's called inclusion, exclusion, which I'm trying to decide if I even want to write that down, or you can write these all down, add them up. So 55, 65, 75, 85, 95, which we had done before. So I'm going to write the 95 people here, and then I'm going to go ahead and write the formula. There's a formula in your book for inclusion and exclusion to make sure we don't count those 20 twice, because if we had added up the 75 and the 40, we would have counted those 20 people twice. So the formula in your book says, I think it's with A's and B's, but it says the number in the union equals the number in C plus the number in T minus, am I going to go off screen? I hope not. The number in C intersect T. So this would be the one we're looking for, and this would be the original 75 plus the original 40 minus that 20 so that we don't count them twice, which will give us the same thing as the 95. I like the Venn diagram and to just kind of count it up, but either way is fine, whichever way works for you. So let's look at this one now. We've got how many students are neither transfer students nor commuters. And that one's a really weird one, neither nor. Some people can read it just the way it is, so we want them to not be commuters and not be transfer students. So we want not those things. And when I say not, I always just cover it up. I'm like, everything that's not that, boop, cover them up. So another way you could write it, how many students are not, and then in parentheses, transfer students or commuters. So not transfer students or commuters. Another way to write that is T or, as in union, C, not. So the opposite of transfer or commuter. So here's our transfer or commuter, which is the same thing as commuter or transfer, but we need not that. And if you watched, I think it was the first video early on in the semester, the way that I do that is I take the thing, the or, And to do not that, I make a sunshine out of it. So the opposite of it is all this stuff out here. So we want not that, which is all the stuff out there, which up here gives us that 5. So if you're asked that, then that's how you can look at it. There's probably other ways too. All right, last question for this one is how many students were transfer students but not freshmen? This one definitely gets some people. Let's draw another Venn diagram. Okay, so clearly there have been some typos here, but this is how many students were transfer students but not commuters. Okay, so we want people that are within the transfer student circle but not the commuter circle. Okay, so and but is the same thing as and, which I kind of mentioned earlier. So this is transfer students, which is a T, and but is like an and, so I'm going to do that. Transfer students, but is the same thing as and, not commuters. So commuter, and I need a red. Commuter, not commuters. Okay, so T and C complement, or T and not C. So, so we need them to be a transfer student and not a commuter. So I'm going to deal with both of these. So T is this, and then I'm going to make another Venn diagram underneath to get at what it is. So T and not C. There's my T. Here is my not C, because not something is the sunshine, right? Is everything outside of it. So not C. T and not C. And when it's and it's a Venn diagram, you need it to be both. So we need it to be both green and the red, the not C. So both green and red are in this right half moon thing. So I'm going to actually draw one more Venn diagram really quick so that we can wrap this up. So we're looking for the people that are transfer students in the green zone, the green right circle, but not commuters. So and not commuters. So outside of the commuter circle. So where both the green and that red overlap is just this area right here. So we go up to where it is here. There were 20 students there, and I'm sorry I used the number twice in these. I don't like it when that happens, but there it goes. So hopefully having these examples of different ways to take the survey information and put it into the Venn diagram and then answer the questions worded different ways will be helpful.